Well, good morning, everyone. Welcome to Homework Help on Momentum number 3. I'm not going to go through all the math for these, but I will go over the conceptual setup for these. If you have additional issues, I'd like to see your work, and then you can come in certainly and get some help. Make sure you have something written down for me, okay? All right, so let's look at number 1. Ice skater moves to the right with a velocity. She's then going to throw a snowball as she is skating. Right, so let's consider what we're talking about here. You have an ice skater, and she's got a snowball, and she's moving. We all know my artistic abilities are limited, but this is what's happening to start with. And then she throws the snowball. So the snowball is going to go this way, and we want to know, I'm guessing, what is the velocity of the ice skater? That's what the question is asking. So here's my before. Here's my after. Let's consider what's happening there, right? That is a type of explosion. They're together and then one goes in one direction and chances are the other one will go in the opposite direction or will just simply go slower in the same direction, but is definitely going to slow down if not reverse course, right? So we definitely have an explosion here. The key thing to keep in mind is that the masses, you either can add them up and then multiply by the velocity for that initial momentum, or you can figure that you can do them separately, but they have the same velocity, right? So the mass of the skater with the initial velocity, and then the mass of the snowball. I probably should have used a different letter, but you get the idea. All right, either one of those will be your initial setup. In the final setup, you've got this one is what you're looking for, right? You're looking for final velocity, and you have a mass and velocity of the snowball, which is separate from the ice skater. So keep that in mind. Whether you work with this one, the top one, whether you work with the top one or the bottom one, the momentum of the combined will equal these two added up. Okay, so keep that in mind. Now, the third part there, or I should say part B, that you're looking at, your second skater. All right, so here comes the snowball. You found its velocity. That was actually its velocity. You found the ice skater, never mind. All right, so you've got this velocity here for the snowball, and here's a second ice skater ready to catch it, right? This guy originally is at rest, right? So you need your MV for this one, pretty easy if that one's 0, right? But then after the collision, right, this guy's holding the snowball, and you want to know the final velocity. Hopefully, based on what we saw over here at the first one, you realize that these two have to be together. So again, you either add the mass up with your final velocity, or you can do it like this. Just make sure that you have the velocity the same for both. All right? So those are my hints for the first question. Read your questions carefully, set them up carefully. Okay, two carts with masses, and they are both moving, but this is the key, toward each other, right? So, I often find it really helpful to draw a picture, even if it's a rudimentary picture. Right? It gives me some idea, right? This way, oh my goodness, check it out. We got to have a negative velocity on this one, and this one's got to be a positive velocity because they're traveling in opposite directions. That's the most common mistake everybody makes, right? After the collision, they are stuck together, which means they're going to move with the same velocity, and it also means that you're going to either add the masses up or you can do them as separate pieces, but you have to consider they have the same velocity at the end, right? So these two added together has to equal that one, right? So you can probably figure out where I'm going to go with this one. Not the same, right? It's a different one. Sorry, it's not multiplied, that's added times your velocity. But knowing that this one is a negative velocity, that's kind of the crux to the problem. That's really the key to solving it. All right, last but not least. Again, let's draw a picture. I think this can really help us. I mean, a chart is good, but a picture is also good. So you've got one billiard ball traveling in a positive direction with a velocity given to you in the question. Elastic head-on collision with a billiard ball of equal mass that is initially at rest. All right, so this one's just sitting here. And then the first ball is at rest, then you can consider after the collision, this one has a velocity of 0. What's going to be the velocity of this one? Well, you know what? They're giving you a huge clue right there. They're equal masses, right? So you might even be able to just predict this without doing the math. But, all right, don't forget your masses. If you say, well, they don't tell me what the mass is, but you know they're the same, you can put any number you want in there. I'd keep it easy. I'd make it 1. That's how I would solve that. Okay, if you are still struggling after those little hints and help, make sure you come find me. I will be back to school on Monday, and so will you. So we'll see each other before school or whenever you have a question. Okay?